Ever since we first looked up at the night sky, we've been asking the big questions. How did all of this begin? But there's another question, the flip side of that coin, that's just as massive and maybe just a little bit scarier.
Yeah, that one. If our universe exploded into existence with a Big Bang, does it also have an expiration date? And if it does, what's it going to be? A spectacular finale? Or just a quiet fade to nothing? Well, let's get into it, because the answers scientists thought they had for decades might be changing as we speak.
For a long, long time, cosmology had a prime suspect for how the universe would meet its end. It was this long, drawn-out scenario that pretty much everyone agreed was the most likely, almost inevitable conclusion to everything.
And that leading theory is called the heat death. Sometimes you'll hear it called the Big Freeze, which sounds a bit more dramatic. But really, it's a fate that isn't dictated by some big, flashy cosmic event, but by one of the most basic, fundamental laws of physics. And it all boils down to one word: entropy. You can think of it as the universe's one unbreakable rule, that everything, and I mean everything, tends to fall apart. It's why a hot cup of coffee always cools down to match the room's temperature, right? It never just spontaneously gets hotter. Order over time always surrenders to disorder. It's just the way things work.
So the second law of thermodynamics just takes that simple idea and blows it up to the scale of the entire cosmos. It predicts that eventually, all the useful energy in the universe will have spread out so evenly that there are no temperature differences left, anywhere. Everything becomes this one, uniform, lukewarm temperature. And without those differences, without that energy gradient, nothing can happen. No stars can light up, no chemical reactions can occur, no life can possibly exist. The universe just runs out of steam.
And the timescale for this whole process is it's almost impossible to wrap your head around. We are talking about 100 trillion years from now, before the very last stars flicker and die. Then, trillions upon trillions of years after that, matter itself, the protons in every atom, might just fall apart. And after a googol years, that's a 1 with 100 zeros after it, even the last gigantic black holes will have evaporated into nothing. What's left? A vast, cold, dark, and perfectly empty void, forever. That's the heat death.
So for the longest time, that was the story. A kind of sad, incredibly slow fade to black. But what if there's a plot twist? What if the main character in this story, this mysterious force we call dark energy, isn't playing by the rules we thought it was? Turns out, in March of 2025, a paper came out analyzing a ton of data from something called the Dark Energy Survey, and it just blew the whole case wide open. It suggested our core assumptions about the universe's end might just be flat out wrong. The clues are pointing to something really different about the very force that's been pushing our universe apart.
So here's the bombshell finding. The paper basically said dark energy isn't what we thought it was. For years, the best idea was that it was a cosmological constant, which is just a fancy way of saying it's a steady, unchanging push that expands space. An idea Einstein himself came up with. But this new data suggests it's something more complicated, something that might change over time.
Okay, to get just a little technical for a second, physicists measure dark energy's behavior with a number they call W. If dark energy is that constant, unchanging force, W should be exactly -1, 0.0. But what the Dark Energy Survey actually measured was a value closer to -0.948. Now, I know, that looks like a tiny, almost meaningless difference, but let me tell you, in cosmology, a difference like that changes absolutely everything.
So what's the big deal? Well, if dark energy isn't a constant, that means its strength can change. Think about that. It's been pushing the universe apart for billions of years, but what if, in the distant future, it starts to get weaker? What if the expansion of the universe isn't a one-way street after all?
This single possibility completely changes the game. It resurrects a much older and way more violent theory for the end of the universe. It's a theory that most scientists thought was dead and buried, the Big Crunch.
The whole idea is actually pretty simple. Imagine a cosmic tug of war. For billions of years, dark energy has been winning, pulling the rope and causing space to expand faster and faster. But if dark energy starts to get tired, if its pull weakens, then gravity, that constant, relentless force pulling all matter together, could start to win the war.
So suddenly, we've got two completely different destinies on the table. Instead of expanding forever into a cold, dark nothingness, the universe could slow down, stop, and then reverse course. Everything would start falling back in on itself,
Galaxies, stars, planets, all of it rushing back together, accelerating towards one final, fiery, cataclysmic point. And unlike the basically infinite timescales of the heat death, this new model gives us a much closer deadline. If this theory is right, the universe will stop expanding in about 11 billion years. That's it. That's the cosmic peak, the moment it all starts to collapse.
You have to admit, this creates a kind of stunning, cosmic symmetry. Our universe began in an infinitely hot, dense point, the Big Bang, and now it looks like it might end in an infinitely hot, dense point, the Big Crunch. It's a story that could literally start with a bang and end with a crunch. It's almost poetic.
So, where does that leave us? Are we doomed to freeze or destined to burn? The truth is, we don't know for sure yet. This new data has reopened the investigation, but the final verdict is definitely not in.
Now, we've mostly talked about the two big ones today, the long, cold goodbye of the Big Freeze and the fiery reversal of the Big Crunch. But you should know there's actually a third, even crazier possibility out there called the Big Rip. In that scenario, dark energy gets stronger and stronger until it literally tears everything apart. Galaxies, stars, even the atoms that make you and me.
But here's the most important thing to take away from all of this. Science isn't just a book of facts we read. It's a process, a constant investigation. The final chapter in the story of our universe is still being written, and every new piece of data, every new telescope gives us another clue. We're not just passengers, we're actively figuring out the plot as we go.
And so that leaves us right back where we started, with the ultimate question. We know for a fact our universe had a beginning. But will its end be a silent, gradual fade into an icy darkness, or a final spectacular fire, mirroring the one from which it was born? For now, the cosmic investigation continues.